Yeah, hello all, good evening. Today we are going to look into design patterns in data engineering. Yes, today we will explore some topics that are used in modern data engineering world. What are the design patterns that top companies like Netflix, Uber, Airbnb, LinkedIn, they all use these patterns daily to make their data systems very scalable and reliable. Let us look into those design patterns. Design patterns are reusable solutions for common problems that are encountered in model building pipelines. These patterns are evolved from industry best practices. Let us look into them. This is Lambda architecture, guys. When you want both speed and accuracy in your data pipeline, we will use this Lambda architecture. So what is happening in this architecture? You have two layers. Batch layer, which is usually stored to, used to store huge historical data sets. Usually the language you use to process the data from batch layer will be Spark or PySpark. Like Spark is a framework where you can run Python, which is called as PySpark, Python version of which you can run on Spark. Java, Scala. See, historical data, historical analysis, historical data processing that is working with huge data sets at a time. You can read that data from batch layer. You can do that processing from here. And finally, you put it in the serving layer. And the serving layer for such kind of data will be something like we have Gen AI applications, machine learning models. That will be the serving layer. Finally, these kind of processing tools will use data from batch layer and put it in the serving layer. Like they will come up with an endpoint which does the forecastings or predictions. And speed layer is for real-time data. When your serving layer needs sub-second recommendations, still the recommendations has to be accurate. For example, something like stock market changes you have to show, and how customers are visiting the web application for an every minute or every hour, how it is changing hour to hour, like in the morning, evening. You have to show these insights. How many orders placed so far? So all these things, if you want to show, then definitely you will plan a speed layer. And I have an example here. Netflix uses both Lambda architecture to process billions of events daily. The batch layer process historical viewing data using Apache Spark. Okay, and it uses speed layer whenever it is necessary. And you already know where this speed layer is useful when you want um, things, when you are searching for something, it has to show you the response as soon as possible. You're using the chat box from the same application, then you definitely all this has to be planned in speed layer. Now the data which is used for regular processing for personalized recommendations, then it will be done from the batch layer. And user logins, user searches, all these data will go through speed layer, and accordingly the underlying databases will be planned to process this data. Not only databases, the processing tools also. In batch layer, usually for data processing, people will prefer Spark. In speed layer for data processing, we will prefer Flink, which is capable of handling data in real time processing. That is Lambda architecture when your system needs both real time as well as historical accuracy. Now, Kappa architecture. when you have everything streaming, you don't have batch layer, you don't want batch processing, and for real-time data speed layer, you don't want two different layers in your architecture. All the data is coming in real time. Then you go for Kappa architecture. Yes, it is all real world. Data will be coming in real time. You will be processing it in real time, saving it real time. Um, Kappa architecture simplifies the things, and this is for pure streaming platforms. Let us look into the example LinkedIn. LinkedIn uses Apache Kafka based architecture. They'll get 7 trillion messages per day. All the messages from the LinkedIn will be collected by the Kappa architecture. All the data flows through the Kafka topics, enable real-time analytics and historical batch processing through stream replay. So there is no batch layer, even though batch processing is happening, that happens through stream replay. From the same Kafka, it will go back in the time and get the data. Like it want to do some batch processing for all the messages that came in that particular day. In the same Kafka, which is used to collect the real-time data, it will go in the time, replay all the messages in the Kafka and do the batch processing. When you don't have huge amounts of data, applications like LinkedIn, which is just like messaging, their personalized recommendation, these kind of things will also happen. But if you look into its messaging system, it is planned in Kappa architecture. Only streaming, that is collecting data in real time, processing it in real time, and also historical batch processing will not use separate database or a separate storage. It will just use the same messaging system which is used to collect the data in real time. That is a difference, Kappa architecture. But here there will be historical data in data warehouse or data lakes from where historical data processing for something like recommendation engine happens here. And wherever analysis that has to happen in real time, like calculating the number of customers, click streams, monitoring, customer registrations, all this happens through speed layer. We have more architectures. Medallion architecture. Okay. Lambda architecture, you can plan your medallion architecture in batch layer. It doesn't mean these are separate. These are nothing but design patterns. You can club these design patterns. They can coexist into a hybrid model also. Now let us take this medallion architecture, which organizes your data into 3 layers. Now usually this is more used in batch processing, where your data comes into bronze layer first, that is your raw data. A retail company process 100 TB daily. First it will store raw data. A retail company is having order data and log data, so much of data in its transactions databases and other sources. Daily they will bring them to bronze layer and they'll do cleaning. There will be raw click stream, duplicate data, invalid data. In silver layer, after doing all these changes, clean data will be available there. And in gold layer creates customer 360 views for analytics. Gold layer is something arranging your data into more organized way, depending upon the analytics. If it is dashboarding, splitting the data into facts and dimensions, or if it is something like building forecasting models, then creating feature stores, making aggregations, summarizing the data, that is gold layer. Based upon the customer, creating the data. Now going back, like you can create retention policies to bronze layer, like they'll be cleared up for every 1 week or 30 days. And silver layer and gold layer you will actually maintain. And usually people, to be more storage optimized, they'll create views for gold layer from the silver layer. And bronze layer they'll clear up time to time. And if there is any data loss or any crashes happen, there will be always 3 layers. Suppose if there is any data loss or some mismatches happening, mishaps happening in silver layer, always we can navigate back to bronze layer if we plan our architecture in these 3 layers. That is medallion architecture and mostly used for batch data. You can also implement this for real-time data. As the real-time data comes, it goes into bronze and then, but it is more suitable for batch data. Yes, in batch processing of our Lambda architecture, you can include this medallion architecture. ETL versus ELT pattern. See, all these again design patterns according to the use case, data sources, and who are using the data. And also, if you want to make cost effective solutions, you will look into this. This will help you to rethink which pattern will be better. They are not like standard designs, they are only patterns. You can also like combine multiple patterns together. And every medallion architecture will have a ETL or ELT in it. Every batch processing and streaming will also have ETL or ELT in it. And Kappa architecture also have ETL and ELT. Extract, transform, load. Basically, you're extracting data from sources, transforming it, and loading into a final target storage, which you feel should have a right data. And from there, you'll start analytics. Now, before doing that extract, transform, and load, extract is one phase, transform is one phase, and load is one phase. Which is better? Transform data before loading or transform data after loading? See, today we have very advanced modern warehouses like Snowflake and many other. Snowflake's architecture enabled a shift from traditional ETL to ELT. See, if you extract, transform, and load, for example, you are getting 10 TB of data daily from particular source. Yeah, from any source. Sorry. Then you extract 10 TB of data, do processing, and then load into some data warehouse like Snowflake, which needs lot of compute power, right? Obviously, for processing, you have to arrange the compute cluster and it has to be up and running. It has to continuously collect the data, transform the data, then only you are placing it in your target data warehouse or any other storage like data lake houses. Yes, that is good. But if you put ELT, extract the data first. Don't spend time in processing. It's not for real time. You're not you don't want any real time insights now. You are collecting the data so that you analyze it and get more better insights, like creating personal recommendation engine, customer behavior analytics, forecasting models, or creating dashboards based upon the historical data, not real time. Then instead of processing and saving it, just save it in its raw format and then start cleaning it, transforming it. And companies found it more five times faster data availability because you will get data quickly into your analytics platform like Snowflake, that is data warehouses from where you read data for analytics. And if your data is something like structured data, they won't be needing much transforms. So instead of extract and apply data validation, data quality rules first bring in data and load it and then transform according to your analytics. Their infrastructure costs also reduced by 60%. Then you don't need your compute cluster up and running all the time. So that is the advantage. If you think you want transform first or transform later, depending, instead of doing ETL every time. In some scenarios, ETL is required, extract transform load. When you get messy data, obviously filtering the data is more good before bringing all the data and dump it in your data warehouse. So according to your data sources and end users or end applications, choose whether ETL or ELT pattern is useful. Event sourcing pattern. Actually, the Uber started this, and also example we have is related to Uber only. This event sourcing stores all changes to application state as a sequence of events. Like ride start, location update, payments, any status change that like client or customer makes to like change in pickup point or drop point. So every event, I mean change that happens to the application is an event, and it is like saving all the events. Not quite sure how to. Sorry, yes, just give me a minute. Yeah. Yes, and it stores every event and 100 million plus events daily. Like event right status, change payment, you can see. And complete audit trail will be done for compliance and ability to replay the events for debugging, everything. Because it is event-based application. You can book rides, cabs, right? So they are saving each and every event that comes from the application rather than only transactions or bookings. Each and every event is saved and then it is used for analytics, for audit trail, compliance, analytics. CDC. This is like a good old architecture which we use in many pipelines, especially when you are getting data, something like transactional databases, OLTP systems. We will use CDC. We are interested in capturing the data only when changes happens. That changes might happen daily or once in a while. That change can be insert or update of the existing records in a table, or it can be a delete or upset, insert as well as update, both at a time. And we want to trigger our pipeline only if any change like that happens. For example, customers registrations, customer database is there. Whenever new customers are registered, for example, a telecom company or a banking sector, whenever new customers got registered, then only we are interested in collecting that data. If some customer changes their address, then we should also capture that change. If bank removes any customers from their system, we have to capture that change. Only when changes happens, we want to collect that data. That is CDC. Change data capture. Usually there are tools. Airbnb uses Debezium. It is an open source CDC tool. What it does, whenever changes happens in its MySQL database, this DBC tool will pick up the changes and put it into the stream because we want to track the changes as soon as possible. And these feeds are updated in the data warehouse. Change in a location or change in a property name. that are already went to data warehouse. Every day the data is going to data warehouse. Now change happened to the systems, transaction systems, which is used by applications. Now that changes will also be should be there in data warehouse. For the old data in the data warehouse, we should apply those changes. And that is where we will use CDC tools. Okay, now CDC captures the data. Then how you're going to apply that change to your old data? So that pattern is called as SCD. For example, I'm very sorry, yes. Yes, CDC will capture the changes and how to apply these changes to old data. For example, a brand name has been changed. There is a e-commerce site, let's say, and this e-commerce site is having all the product data, order data. Let us say order data. Order data will obviously have brand, what is the product brand, and the quantity and customer ID, all this. And every day, that day's orders will be moved to data warehouse. Now let us say the product brand name got changed. Okay, the new data will go to data warehouse with the changed brand name. What about the old data? Old data should also get updated with the changed brand name. Not just with the new brand name, the old data should save both old version of the brand name and new version of the brand name as well. And this can be applied using a pattern called SCD, slowly changing dimensions. They are not like transactions that happened with, or something like data that Uber bookings, or not something like sensor data that is measured for every minute. All these are called facts, events. They'll be generated continuously, and of course there will be change in that data, like price, quantity. If you take sensor data, attributes like temperature, humidity. If you take Uber data, location, pickup location. If you check a data set, you will be changing. These attributes will be changing. They are measures and there will be dimensions. They'll be static. Write something like SKU ID, product code, country, address of a customer. They'll not change very frequently, but we can expect a change very slowly. Very slowly. Some might not change, some might change very slowly. And to track those changes and apply eventually in the target also, that is in data warehouses or lake houses, the pattern we use is called as SCD. And there are different types of patterns. See, today we have all these systems like banking systems. Now and then we will change our addresses, names, date of births. Now, depending upon that change type, to track the changes, we have different types. Whether to like save the old version. If you don't want old version, then use type 1. You want old version also, type 2. Old version and new version. How you want to handle that slowly changing dimensions? We have types. This is one design pattern which helps you to apply the slowly changing dimensions. Okay. And what applications uses this accurate historical reporting, customer lifetime analysis, fraud detection through address design analysis, and then data vault. See, this data vault is used by banks. When you want to handle different source systems, and it has to be fully scalable, you want to establish relationships, you want to create vaults, establish relationships, like link the ships, sorry, satellites or the descriptive attributes. And real world example, major banks uses this data vault. So what they'll do, they'll manage complex regulatory requirements and frequent schema changes using hub tables, which store customer IDs. Link tables track account relationships. And when you are using, the same customer is accessing the banking website from the multiple sources. Like we have banking digital applications, and we have online, and we have ATMs, and different sources are there. And these are like satellite hubs which capture the actual data from different sources. And eventually they are linked with customer ID stored in the table. See, you are establishing a link with the customer ID, and satellites are these different tables. Table from online banking, and we have UPI banking, and we have a few other transactions, right? Transaction sources. All those are satellite tables. And all the satellite tables has a relationship with a customer ID that is there in the main table. That is hub, which has the business keys, customer ID, location, or customer details will be there. That is the business key, transaction type, all these will be the business key, account ID. And business key will have relationships with satellite tables, online banking table, offline banking table, ATM transactions table. And why? Because after doing transaction, if I go and check my account, it should be immediately reflect. I should be able to see that amount got deducted or transaction success, debited or credited almost immediately. When you want to fetch data like that from multiple places, then we will use this design pattern, data vault. And finally, we have in microservices architecture, where each services manages its own database. We will use database per service pattern. Like we know different microservices today are there. If you take e-commerce site, it is getting bookings. Bookings will be processed by a different microservice. And this is not very widely used database, because if every microservice has its own database, then it will be hard to process your data. Right? If in an e-commerce site, if a microservice which is handling the orders, it is taking the order, giving the acknowledgement, giving some tracking ID. If it has own database, and orders itself has one database, then it is hard to process your data. You have to read data from multiple systems at processing level or analytics level. So it is not very wide in use, but that is also one design pattern, since we are talking about design patterns. In scenarios where microservices are very independent, they can have their own databases without much dependency. And finally, when to use what? Lambda architecture is a mix of both batch and real-time workloads, but complexity is high because in one system you are bringing both and mixing both at one platform. And that too, today we have cloud architecture. Suppose if you are doing designing on open source stack, then the complexities might be high. Kappa architecture, pure streaming use cases. Simple because just collecting streaming data only, dealing with that data only. And when to use medallion architecture? When you have a platform like a data lake house where you can dump in raw data and silver, gold. Like basically, a platform should support to save data as it is in files, log files, text files. And later you should be able to create tables after your processing in the same platform. Then this bronze, silver, gold layer will be best design pattern if you are working on such kind of platforms. ETL, ELT, it depends. We cannot say like how is your data? Is it messy and it has to be used immediately, or it is structured? It is used whenever analytics will pitch in. You are just saving the data. Accordingly, you can choose. We cannot say, but some example tools which does ETL and ELT. Event sourcing, audit trials, time travel, you want to do these things, then just save events as it is. One event will be like with key value pairs. Save the entire event. Don't try to split it into rows and columns. That is saving events as it is. Data vault for enterprise data warehouses. Okay. Some best practices case. Start simple and evolve gradually. You can merge more than one pattern also. Yes, that is about data design patterns. Thank you.